Hi, good morning, everyone. I'm Brad Green. I'm a director here at Google, and I'm in charge of the AngularJS project. Today, we're going to be talking about the mean stack. This is a little bit different than things I usually talk about. Angular is a client-side templating framework, but it's not a full picture. It's only the part that runs inside the browser. Today, we're going to talk about the other pieces that you might select as the backend, the server pieces for your application. Today I'm joined by Valeri Karpov from MongoDB, Ward Bell from IdeaBlade, who's going to be talking about BreezeJS, and then Al Sang from StrongLoop. And we're going to start off with Val, who coined the term the mean stack, and mean standing for Mongo, Express, AngularJS, and Node. And Val, would you take us through a little bit about the history of how you came to pick this stack and why you thought it was a great idea?
Absolutely. Thanks, Brad. Let me just pull up my my slide. Cool. So hi guys, my name is Valeri Karpov. I'm currently a kernel tools engineer at MongoDB, and I am the one who originally coined the term mean stack in a blog post on the official MongoDB blog back in May. You can here's some links to some of my other stuff if you're interested in reading more about the mean stack. But let's get started. So a little bit more about me, just so y'all don't think I'm some random guy on the internet. A little bit of my backstory. I was originally the CTO of Scavenger, now known as Level Up. I've been using AngularJS for a very long time, since 2010, mostly because I follow Mishko Hevery, who originally wrote the libraries, working very closely because I was an intern under him in 2009. I got started using the mean stack when I was working on the Ascot project, which was a fashion tech startup that we'll be talking about a little bit later. And that startup has since folded. I'm currently working for MongoDB on an internal continuous integration project. So what are we going to be talking about? The talk will be about basically why my team first started using the mean stack for Ascot project and why we ditched Ruby on Rails, why the mean stack is great for prototyping, and how the mean stack makes automated testing super easy. So, as Brad mentioned, the mean stack stands for MongoDB, ExpressJS, AngularJS, and Node.js. A little bit more about each of the individual components. MongoDB is a document database that seeks to bridge the gap between a document store like Redis and a database like your standard MySQL. We want to get you the performance and ease of use of a document store with the rich feature set of an SQL database. So you can do things like build indices, use a rich query language, and do aggregation. But what you're storing is essentially objects. You're not trying to fit things into columns. You're just storing what is semantically a JSON object. ExpressJS is a light web framework on top of Node.js that gives you a bunch of helper methods to write out routes and do MVC on the server without obscuring the things that make Node.js particularly awesome. AngularJS, you probably have heard a lot about it. I like to describe it as basically a magical library that makes everything client-side super easy. And Node.js is an event-driven I/O framework for JavaScript that runs on the server side, essentially letting you write a very concurrent server very easily. So the origins about the mean stack. The team that I was working on Ascot project with was my team from Tiger Labs, which is an incubator program from 2012. We're working on a project called Tonight Life. Now, Tonight Life was essentially a events aggregation framework that basically showed you cool events that were coming up in your area, hand curated by our team. We had an AngularJS client for the web, and then we had our iOS and Android clients as well. The Rails backend and the combination of Angular, iOS, and Android was not particularly the best way of doing things. We had too many testing tools and no way of sort of integrating all of them together. So when we had a little bit of unit testing on the server, we had some unit testing for Android and iOS clients, no real unit testing for Angular. So all these testing tools ended up being a mess. We couldn't sort of test the integration between all these tools. We also had a lot of different HTTP requests going on. Every time somebody hit a route, we would often be hitting the Facebook API 3, 4, 5 times. And in order to get that to work fast, we would have to make these HTTP requests concurrent, basically running at the same time instead of blocking the server while they were out. But when you start introducing threads in Rails or in any other language, you introduce extra complexity and you introduce a lot of room for bugs. And we ended up running into a lot of odd race conditions. And finally, debugging database interactions was a bit of a pain. We were using Active Record, which is an ORM, object relational model, that took the objects that we were working with on the server side and converted them into a bunch of SQL tables. Now, the ORM did its own magic, so we were not able to sort of see objects on the client side, and we couldn't really see how they would look to the server and how they would look in the database after the ORM was done with it. And all of this added up to us having about 2.5 developers and 5 different languages, SQL, Ruby, Objective-C, Android, and JavaScript, that we had to sort of juggle in order to get our product to work. So when we decided to fold on to Nightlife, we decided that we needed something different for our next project. And that's where the Ascot project came in. We decided that for the purposes of building out a clean, simple product that would work always, we wanted to basically build it in one day and go to a hackathon, Angel Hack, in Washington, D.C. in November 2012. For that, we settled on the mean stack minus Angular. The part of the reasons behind that is, one, we wanted to have a very simple data model. So Ascot project's business was essentially being able to tag product information in images. You would have this overlay that would show you where this product was in the picture and where you could buy it. And then we would convert affiliate links from the buy links. Now, with MongoDB, we could easily store this all in one collection, as opposed to having separate tables for tags and for products and for images, which made our lives a lot easier. Also, we could do parallelization much more effectively in Node.js, simply because Node.js is event-driven. It's all through callbacks. So we didn't have to write any threads. And on the back end, every time you saved an image, what we would do is we would basically ping out an HTTP request to several different affiliate link providers and sort of get ourselves the best affiliate link for the particular buy link. Originally, we decided to go without AngularJS because we had some trouble with it previously when we were working on version 0.9.19 was the one that we were using for Nightlife. So we wrote the tagger in jQuery, and that turned out to be a terrible, terrible, terrible idea. We had about 800 lines of spaghetti code in jQuery that we would never be able to maintain. So we rewrote it in Angular. It ended up being about only 80 lines of code, and we had 100% test coverage or unit test coverage on it, which was absolutely perfect. So the philosophy of the mean stack and what we believe that this stack should be able to help you do. Ideally, any web stack should help you prototype, be able to build your product as fast as possible and get it out there into the hands of your users. Should be able to test it automatically so that you never push legitimately broken code. Your product will probably always work as advertised. And adapt, you want to be able to change quickly, iterate on feedback, and make your product awesome for your users. And then you want to scale. You want to make sure that you can both add add more machines to your server deployment easily, and be able to utilize the resources that you have as well. Now, what we're going to talk about in this talk is only the first 2 steps, because the other 2 steps will require a separate talk all in themselves. But we're going to talk about sort of how you can build, what the mean stack gives you to enable you to build a usable product very, very fast, and then how you can also test that product so your users never see your code break. I'll sum this up as build fast, don't break things, sort of the opposite of the Facebook philosophy of move fast and break things. Works well for Facebook because they have a lot of users and everybody uses them, despite the fact that their code is broken quite often. As a small startup, I don't believe that you can afford, or as a small new app that you're trying to get people within your workplace to use. You don't want to ship broken code because you're losing your users' faith in your product. And every time something breaks where it shouldn't, that just means people are less likely to be using your product. So let's talk about what enables you to build fast with the Mean Stack. One, it's super easy to set up on Windows OS X and Linux. You can check out the guide. You can check out a setup guide on my blog. All you need to do is install Node.js and MongoDB. And again, I will put this up on SlideShare after this talk. So don't worry too much about having to click that link immediately. But one of the problems that we had with Rails is, I don't know if you guys ever managed to successfully set up Rails on Ubuntu, but I spent several hours one afternoon last summer doing that, and I still could never get it to work. So thankfully I've punted on that, and now I get work done on my Windows 8 machine, on my MacBook, and on my multiple Linux servers, and it works as advertised on all of them. The other big advantage of the Mean Stack is, since you're writing the same language, you're storing the same objects on all levels. Now, the dream with Node.js was the ability to basically write your server in the same language as you write your client. MongoDB adds and sort of completes that promise and enables you to store what are semantically JSON objects in your database and then query using JSON as well. So here's a simple example of how this looks. This is the Mean Stack to-do repo on GitHub. I will post a link to that here or in a later slide. The UI essentially allows you to create a task or to-do similar to what you would in your Gmail. So we're going to say, I want to finish my Mean Stack talk, and it's due on October 3rd, which is today. And so Angular, if you're not entirely familiar with how AngularJS works, the one feature that basically makes it as magical as it is called two-way data binding. Two-way data binding gives you the ability to declare an HTML element and with an attribute to the HTML element, say that the contents of this particular element should be tied to this particular JavaScript variable. So when the JavaScript variable changes, the contents of the HTML element change. And when the contents of the HTML element change, like this text area that you see on your screen, you will the JavaScript variable will change to reflect the new value as entered by the user. So here I just typed in finish Mean Stack talk, clicked on October 3, and my JSON object has changed to reflect this particular state of affairs. So I have a new to-do, finish Mean Stack talk, due October 3rd. And this dynamic template will be passed as is down to the database, as we'll see in the next slide. So this is some output from Node.js. I've started my Node app. I'm running it from the command line. And when I click the add button in the previous view, I do a post to to-do.json, and this is the output. This is some logging output that shows you the JSON object that I get on the server side. And as you can see, the server has pretty much the same view of the object as the client did. Basically, it's JSON, the same fields, with the addition of an _ID field for the convenience of MongoDB in order to be able to index on that. And then when we save over to MongoDB, we can pull up the MongoDB shell, which is actually legitimately, you interface with the shell using JavaScript, and MongoDB stores what is technically a superset of JSON, but when you're dealing with JavaScript, it is exactly JSON. So the MongoDB shell will show us the exact same object as passed as we saw on the client, with the addition of an ID and a _v, which is a version number that the Node.js layer occasionally adds. With MongoDB's dynamic schema, basically with MongoDB you can store anything into any table or any collection that you want. MongoDB calls it the equivalent of an SQL table is a collection. There's no need for rake. All you would need to do to be able to insert a different type of object is, well, nothing. You could wipe the database, you could wipe your collection, and then start putting in new types of objects, but you don't necessarily have to. So what is the advantage of this? Unless you're doing server-side validation, you only need to change your HTML to store different data or different data types in your database. So if you're going to build something very fast and you don't necessarily care about doing things like making sure that the data being inserted is correct, because the only people that are going to be using it are you and your handful of selected testers, you don't necessarily want to waste the time trying to say, okay, let me say this column is going to be a 32-bit integer. No, it's just a waste. I want to be able to say, okay, input type equals number. Let me add another input type equals number that represents some different field, and all of that is going to be passed to the server and to the database as is. This makes it very, very easy to write a usable product very fast, and then add server-side validation and sort of sanity checks and correctness checks later. It's also easy to debug because your database is going to look exactly the same as what your client sees. So you don't have to worry about mentally translating, okay, this is how my object looks in JSON, this is how it's going to look in the database in all of these different columns. It's going to also lower the barrier to entry to understanding your code base, because you're only writing JavaScript and storing JSON. You're not going to be writing SQL queries, writing Ruby on the server, and then writing JavaScript on your front end. There's a little bit of a limitation to this. If you have multiple clients or don't necessarily serve up your JavaScript with each page load, you might have some difficulties with changing the underlying routes, but that's a problem for after prototyping. And don't break things. Automated testing makes life super easy, and when you only write JavaScript, you only need a couple of testing frameworks, and all of your integration tests come for free with Angular Scenario. So Karma, if you haven't heard of Karma, is a phenomenal test runner that allows you to basically launch a bunch of browsers and run all of your client-side, server-side, and Angular Scenario end-to-end tests automatically each time you save. This makes it very, very easy to basically just change code very quickly and make sure that you haven't broken anything that is of any significant importance. Again, Angular Scenario does a great job of sort of giving you a smoke test of, have I broken any particular page or flow that the user depends on. Now, nowadays, the gold standard of automated testing is called continuous integration. It works in different ways in different places. Google has been using continuous integration, if I recall, since like 2006 or 2007 internally. However, the way that we like to do it at MongoDB is for each commit, you run a huge suite of tests on each Git commit. And Karma allows you to integrate easily with some existing open source continuous integration suites, such as Jenkins, Semaphore, and Travis. You can find more information about that on the Karma Runner GitHub IO. So all in all, this gives the mean stack the advantage that we can basically build our code fast, add things as necessary, and then be able to automatically test from the very beginning, basically getting the gold standard of automated testing, continuous integration, for free right from the start, instead of having to bake it in later. So that's all I have. Thank you guys very much for listening. I look forward to hearing the rest of the guys from IdeaBlade and StrongLoop talking now. So thanks for listening again. Have a good one.
Val, thanks a lot. So I'll remind folks who are out in the audience, we'll probably have some time for questions at the end. And there's a link at the top of the YouTube live page that you can click on and type a question or vote on questions that you see there. So we're going to move now to Ward Bell from IdeaBlade to talk about BreezeJS and its role in simplifying managing the data streams that come from the back end.
Well, that's hi. I'm Ward. I'm going to flip over to my screen here, and I trust that you are now seeing. Yes, you are. You are now seeing my screen. So, I'm here to talk about the mean stack as well when it intersects Breeze. Hi, I'm Ward Bell. There's my Twitter handle, and there's my Breeze Twitter handle. And I am a founder of IdeaBlade. We are a company that helps people build business applications, forms over data applications mostly. And we do it with infrastructure products and also professional services. We help train, mentor, and in many cases build the applications for our clients. And these days, did I have that? Yeah, I'd say that about let me back up. The kinds of applications we're talking about here with respect to Angular are single-page applications, applications that are written in HTML and CSS and JavaScript and are executing predominantly on the client. And in our practice, we're seeing about 50% of our current engagements are building this kind of application. You don't want to start from absolute scratch, so we're recommending for a presentation framework where most of the time we're recommending Angular. That's what people want. That's where the momentum is, and we go where they go. We actually think it's great, so how nice is that? And then for data management, we're recommending a product that we've written. It's open source called BreezeJS. So here's what I want to talk about. I want to talk about why you might be interested in Breeze for your Angular application development. I'd like to show you how Breeze works in action. And then I'd like to show you Breeze as it relates to the
Just a minute, folks. Let's see. Ward, can we hear you again?
How about that? Can you hear me now?
Yes, we can.
Okay, we seem to have lost the screen share, so let me try that again. You're now seeing it. Okay, I'll pick it up.
Great.
So I was saying that Angular is a presentation framework, and just a second. What I mean by that is that it helps present information to users and then respond to their input. It's a framework to help you do that. It's a library to help you do that. And that means that you're focusing on putting information on the glass, moving from screen to screen, binding data to the DOM. Those are its primary capabilities. It has some other supporting ones, but that's really what it's about. And we often talk about the patterns that are in use: MVC, MVVM, MV whatever. It's model view controller, model view model. But where's the M? Where's the M, the model? And I think for many people first approaching their single page apps, they say, well, I'll just make a bunch of AJAX calls and I'll bind the results. And if that's what I want to do, I can reach into the Angular bag and pull out $HTTP, or I can pull out $resource if the backend is written as in a REST style. But I want to suggest to you that this view is incomplete. Because in business apps anyway, it's not really a matter of making an AJAX call and then grabbing the data and throwing the data onto the screen. And I want to put some pressure on you on this thought that $HTTP is just a way to access JSON data. Now you could come back to me and say, do I really need any more? I know I'm going to have to write some code, but seriously, what do I need a library for? So I want to ask you some questions about your application. I'm going to ask you a series of questions about your application, and I'm not going to give you a chance to answer, but I'm going to give you a chance to think about. So my first thought is your model all one type, or does it involve multiple types? I mean, how many times do you do a to-do application? I don't write to-do applications, and businesses generally don't. Instead, they tend to write applications that have multiple entities, and these entities, are they interrelated? Well, let's take a look at a really classic one. You got customers and orders and line items and all of that other stuff, and you expect to be able to move from one of those to another. So when you think about this complex object graph, how often do you retrieve that? How do you retrieve it? Do you retrieve the whole graph at once, or do you retrieve parts of it? When do you retrieve it? My impression is that people don't grab the whole database and load it all at once. So how do you maneuver around in this? How do you get from a customer to an order, from an order to a line item over time on the client side? Ask yourself of this data, are any of the data really truly stable during the life of the session? Shippers and products and suppliers aren't going to change. Customers' orders and line items do. So should you prefetch and cache these stable items in order to make your application perform well? How are you going to populate pick lists? How are you going to relate those pick lists to the customers and orders and line items that reach to them? Do you have multiple views of the same object? Angular's all about creating multiple views. So for example, if I had two applications here, I might have the speaker on one screen and the speaker on another, or I might have an editing screen as well as a display screen. Same object. How do I maintain that object across screens without making extra trips to the server? Do you save all the changes immediately? A lot of demos I see, you change the name and boom, it gets saved. That's not the way most business applications work. You often have workflows, and you're accumulating information before the user's ready to commit it. They accumulate changes during workflows. So how do you know which entities are dirty? How do you know which ones are going to save when the time comes to save them? You can't save everything. It's also the case that during a workflow, you'll have some inserts, updates, and deletes. If you're modifying an order, you'll probably add some line items, remove some line items. You need to do that in a single transaction. How do you think transactionally? How do you prepare a transaction from the client side? Can the user cancel the changes when they suddenly decide that they didn't want to make those changes after all? How do they roll back to a previous state? Do you have to make another trip to the server? Another question, do you validate changes on the client for a better user experience? I mean, I realize you have to validate on the server in order to get the data integrity right, but don't you want to tell the user right away before they try and save it that there's a problem and help guide them to a solution? Do you think of these validation rules as part of your business model logic? I mean, is it true no matter what view it is on there that email address has to be proper? Well, if they are part of the business rules, why would you go around putting business rules that belong in the model into your HTML? Why would you go in there in HTML5 and add attributes there? And how are you going to get a designer to do that, and how are you going to maintain it? Shouldn't the model drive that UI? Shouldn't the model validation drive what happens, what appears on the UI when there's a validation violation? What if the user closes the browser in the middle of the work? It happens all the time. I go up there, click something, oops. Users do that. What if they had unsaved work? How would you preserve it and restore it? If this is a business application, not just some consumer site, they're not going to be very happy. They're not going to be very productive unless you have some mechanism for doing that. So I don't think you can find answers to these questions just in making AJAX calls with HTTP or $resource. But I think you can find these answers when you're using Breeze. And of course, you could write it all yourself, thousands of lines, or you might consider using a library to help you, just as you say to yourself, well, I could write it all in jQuery, but I think I'd rather use Angular. Let's take a look at an application briefly that just does some of the things that I'm talking about. It's an application that is it's a sample from John Papa. It's about to come out in his Pluralsight course on Angular and Breeze. And here it is in action. When I load it up, I'll just start it up. and there's a bunch of toasts here telling you diagnostically what's going on as it loads it all from, or loads various parts of things, and certain things are happening. I can go in, and it's really about code camps and sessions, and you've all attended conferences before, so I can go and have a session, and I'm going to another screen. Notice I'm pivoting around something that was expressed this way in one view, and then I'm going here. And by the way, I've cached this data, so I'm restoring it from cache, so I don't have to make another server trip. I can, if I whack this like this, I'm getting a response back telling me that there's an error here. Well, that's because I don't know what the title is. But you know what? Life doesn't stop when I don't know what the title is, so I should be able to go away and continue working on other things. Well, but if I go back in, I want to know exactly where I was. That's because I'm keeping a work in progress, which will help me navigate back to the ones that I was working on before. And that work in progress could, as it is in this example, be stored in local storage, so that were I to close this, and I'm not going to, what instead I will do is I will go back to sessions, and I will rerun the thing and say, let's pick off where I left off. That's kind of the equivalent of closing the browser. There it is. Aha, I'm working on it, and now I'm working on that session. So you see just some of the kinds of things that I was talking about in there. Let me go back. So the thing I just showed you, which is a Code Camper sample, and it's available on will be available on Pluralsight, great course, is an Angular app, but it's backed by a SQL database. I want to show you, because we're talking about the mean stack in Mongo and Node and Express. I want to show you another application, also an Angular application, that is written in to talk to Mongo. And let me find that. That's right up here. Wrong one. You can actually get the sample I'm about to show you from our Breeze sample site, and here it is. Here is Za, our pizza place, and we can go and order a pizza. Maybe I want to make my own. I'll pick a price for it, and maybe I want to pick my sauce and meat, and now I know I want to have some salad with it, so I'll come over here, and I've got that. Maybe I'll go back, and I'll add it to my cart, and I can look at my cart. Okay, so this has that kind of Angular move around on the screen kind of thing, navigate back and forth, keep track of your stuff, do validations, make selections, and all that kind of thing. Looks just like a, it could as easily have been written against a SQL database in which you could imagine what the underlying parts are. And in fact, there is a version of this application that does run against a SQL database, but this one is running against Mongo. And I want to show you a little bit about what the implications of that are. Hold a second while I hit Control. That's where that is. So if the data that you had just seen there about they were driving a pizza parlor were represented in SQL, you would see, in individual tables for each of the items: orders, order items, order item options, order status. But because this is Mongo that we're talking to, in fact, what I've got for an order is not, I don't have order items and order item options. I have a document, because Mongo is particularly good at representing things as documents. Of course, not everything can be in the same document, and I'll show you that. So some of the items are sort of like drop-down lists, like what the products are and the product sizes are, and some of them are other kinds of volatile objects like customers, and they're all interrelated. So you still have navigations between elements of documents, but you also have this notion of a document representation instead of a table orientation. And we can play a little bit with that. Here's a view over the order, and you'll notice that I'm just having to be looking at one of them in particular, and I can, oh, by the way, you don't have to deal with primitive types, so here's an address with a dense type. with what we call a complex type, an embedded type. And you have order items. So here is a pizza, and it has options like barbecue chicken. So you see, it's really a document. This is in no way representable as a row within a data table. Now, one of the things that I think is particularly interesting about this sample is that the front end is the same. It's still the same Angular. It's still the same Breeze. But all we've done with a few minor adjustments is switch back to being able to tweak the back end, give you a back end that's running in Node and Express with Mongo, and we've been able to twist the model so that it can deal in Breeze with documents, not just with table structures. And just a quick look. This is, usually the server side is fairly simple. As you were hearing earlier, it's pretty easy to get going in this mean stack. So, you have a simple HTML, but this is the all you have to do on the Express server. This kind of web server, and you figure out what things you want to use, and you figure out what your routes are, and you route those things to, well, we have some Breeze components for Node that make it easier, and you are off and running. As I said, this sample is available to you from our samples page. So that is kind of an overview in which I'm trying to encourage you to think about data as a more significant problem than simply going for Ajax, that you can combine Angular and Breeze, that you can have a SQL backend or a Mongo backend. Breeze is agnostic with respect to that, and so you can have it the way you want it. Maybe you prototype it in one, or maybe you have a hybrid application which has a mix of a Mongo database, a document-oriented database, and a SQL database, and you can unify those on the client side with a Breeze app. Thank you. We'll probably get to the resources later in the show, but I'll just say it now that there are some courses that you can look at on Pluralsight to learn about Breeze, about the application that I just showed you. There's John Papa's course. You can go online with us, and just think that your rich data, it really is a breeze. Back to you, Brad.
Ward, thanks so much. That was awesome. I think Breeze is very exciting. So we're going to go over to Al Sang now. Al is with StrongLoop. He's going to talk about how Mongo can work for the enterprise in the mobile space.
Thanks, Brad. Hi, everyone. This is Al Sang, CTO of StrongLoop. I'll go ahead and get started by sharing my screen. There we go. So, brief presentation. Thanks, everyone, for having me. We're going to go ahead and talk about Loopback. Again, as Brad had mentioned, Loopback is a mobile backend in which you can hook your Angular application to. We're focused on the mobile space. Loopback is an open source mobile backend as a service, or MBAS. And it features Bacon. And I'll get to what Bacon's all about. So real briefly, a little bit about StrongLoop. We were founded at the end of 2012 by Bert Belder and Ben Nordis. There are two core maintainers in Node.js. They've been there since the beginning of the project, along with myself and a friend and colleague of mine named Raymond. We built the mobile backend for Shutterfly.com. As a company, we develop and support StrongLoop Suite. It's our product offering by subscription. It contains three components, so Loopback, the open source MBAS that we talked about. Loopback is built on top of StrongNode, which is a certified package of Node and select certified community modules that are commonly used in the enterprise. And we round out our offering with StrongOps, which is a real-time performance monitoring and operational dashboard. This lets you not only visualize what's going on with your apps, we intend on making it be operational. So actually do something with your apps, scale it, triage it, so on and so forth. As a company and as a good citizen of open source, we also contribute to Node and its rich ecosystem within NPM. So we've done contributions to Node Inspector, Node Reggie, and we continually comb over to the Node universe to figure out what's there in the community that could be leveraged in the enterprise. So let me start by outlining sort of the problem of what we're trying to solve with Loopback. Mobile devices need to get to data. If you think about all the applications running on your smartphone, look at the ones that actually do something useful or productive within the enterprise. they need data. They don't need just data that exists in the cloud that's new or native to the mobile application. They need data that's like your banking data. So this poses a bunch of challenges. Number one, the data itself, there's authentication, authorization, and accounting issues. Oftentimes, the data is not even in the right format, like it's an XML where it's in a bunch of rows and tables. There's too much of that data. Can you imagine if your mobile device asked for the customer master at a large B2C company like the one that we work for at Shutterfly? You get back 6 million plus rows. And then on top of that, there's multiple data sources. Even if you had just one database, you probably have a bunch of instances of that database. And lastly, you wouldn't even want all those devices to be hitting your backends directly. So today, we're going to be centering around our use case and example around this mythical military equipment rental surplus vendor called Blackpool. And in this illustration, we have this said warmonger, and he's looking for an Apache helicopter. And he needs it by tomorrow because he's about to wage war. So from his mobile device, he wants to look up, using the geocode lookup on his device, getting his coordinates, a list of rental locations that might have inventory for Apache helicopters against Blackpool. Once he actually finds something from the mobile device, he needs to actually reserve it. And upon reserving it, he needs to authenticate who he is. Does he have the credit limit, for example? Getting his profile, is he even authorized to do something like this? And finally, post-payment, which sets another set of challenges and transactions. So as you can see, this is not very efficient from doing all from the mobile device. You could, but you'd run into a bunch of issues. Our answer is to basically develop mobile middleware optimized for this use case and leverage enterprise data on the back end. So this is our solution. A mobile backend as a service, or MBAS, you can think of it as an open source parse you control, if you're familiar with the vendor Parse that was acquired by Facebook. So if you want to think about it in terms of mean, think about it as mean gone mobile. Loopback actually utilizes Express.js, so you can use Express compatible middleware by using app.use with your favorite middleware and extend upon Loopback. We basically connect devices to browsers, connect devices and other devices to the enterprise data itself. It's all written in a Node, proven language for mobile backends. We've seen this use case used over and over again, and it's open source, so you can extend on it. And a key differentiator for us is that it's on premises or in your cloud. You decide where to run Loopback. We have SDKs for iOS, Android. We're just polishing up right now. We're developing our JavaScript SDK, and we have Bacon. Bacon is what relates us to our front-end implementation, and I'll talk more about that in a second. And then we have the rest of StrongLoop Suite, which is the bundling of the other components that round out our offering. So operationally, monitor your stuff that's going on in Loopback, as well as the core fundamentals of Node that powers the app. Real briefly then, on the architecture, again, we have Mongo, we have all these data sources. What we've built is basically a layer of abstraction called the data source juggler. From the data source juggler, you get back a model, something that you can actually relate to as a mobile dev. And as you build models and define these models against your data sources, we surface a REST API. We also have a gateway that allows you to secure the API through OAuth2, mediate with it, so you'll be able to change from different content payloads, and it acts as a reverse proxy to multiple instances of API servers. All of this data is stored in a repository in JSON, and we use basically the underlyings of Git and other distributed source control mechanisms so that you can unify multiple loopback instances into one single runtime. Now let's talk about Bacon. Why did we call it Bacon? Well, who doesn't like Bacon? Bacon stands for Bootstrap, Angular, Cordova, and Node. What we're betting on here is a front-end framework for Loopback to develop mobile web apps or hybrid apps. And we're looking forward to partnering with the Google Angular team to carve out the niche for Angular for mobile web. And now I'd like to jump into a quick demo. If you'd like to follow along or follow up with this demo, you can go to our docs page and go to Loopback Quick Start. We have quick starts for all three of our components. And then you can continue on with the bacon sample, which we just released last night on GitHub. All right, so to get started, the first thing you would want to do is get to our Get Started page. If you register on our site and go to our Downloads page, you can go ahead and pick which platform that you'd like to develop in, or alternatively, we have this Neato Cloud9-based IDE in which you don't even have to download anything. You can just start with Loopback and the rest of StrongLoop Suite running in the cloud. From there, as I mentioned before, go to our docs page, and then from the docs page, go ahead and click Loopback, and we have this quick start. So the first thing we want to do is, again, install StrongLoop Suite, and then you're going to go ahead and initialize the StrongLoop Suite sample application. For the sake of time, I've gone ahead and done that, and I've installed it already on my Mac. So I'm going to go ahead and run the application now. And it starts up. And in another browser, let's go ahead and close these. So what you're seeing here is the physical manifestation of a RESTful API for Blackpool. And we have these model entities that are out there, weapons. So you can play with this RESTful API all through this page. So getting a collection of weapons, get a weapon by an ID. We offer very similar syntax to what Mongo has, right? Mongo Query Language has been a fantastic example of being able to get to sort of a JSON-oriented query structure. So in this case, I have weapons. Give me the ones that are effective, that have an effective range greater than 900, and just give me the first three. You can continue to play along with this API. And again, as you build these models and define them against their underlying data sources, we build an API. And what we've done is build an API Explorer. So you can actually go ahead and click on, for example, locations, and get a list of locations, try it out, get back the same JSON output. So that's the API Explorer. So from here, from the quick start, then we jump into the Getting Started guide. And the Getting Started guide basically allows you to consume this RESTful API. And we're going to go ahead and do that now. And instead of using our mobile client that we have for natively for iOS, we're going to go ahead and use Bacon. So what I've gone ahead and do to save time is clone the Bacon repo, and I'm going to go ahead and run the client. So normally I would do this in the emulator on Android or on iOS or whatnot, but I'm going to go ahead and do this in the browser because this is a little bit hard to see here. So let's go ahead and run the same thing going on in Chrome. And hopefully that's a lot bigger and better to see here. So this is our Bacon app. It's all in Angular. In fact, let's take a look at the code. Really simple. In the main, we have a bunch of routes defined. We've defined our resource route, which binds my local host, the RESTful API coming from the sample app, to the Angular SPA. We have a bunch of controllers that actually drive the logic. And as I move on to the tutorial, if I go to page 1, this is just text. This is lesson 1. And I'll get to lesson 1 in a second. We have a bunch of services that we've defined as well as an Angular module. So we've actually defined this model called ammo and bound it to the RESTful endpoint. Same thing for weapons and locations. Really simple stuff. Okay, so going back to the application. So lesson 1, so to illustrate the power of Loopback, what we've done is we've basically developed 3 lessons to show the key highlights. So lesson 1 is all about the model and having a schema-less definition of what that model is on the database. And what I mean by that is if I actually go to models, the models directory, and I look at ammo, you can see that its properties are null. And in my Angular app, I've gone in and defined properties that I'm going to go ahead and put in. So name, caliber, and a Boolean on whether or not it's armor piercing. So let's go ahead and curl this application's data store. We're using the in-memory database, which mirrors exactly like Mongo, except it's not persistent. And I get back null without its carriage return conveniently. So using the Angular app, then I'm going to go ahead and hit the send request. So super duper ammo, recurl, and boom, there you go. Same thing, railgun, 80 cals, absolutely armor piercing. Whoops. Oh, stuck on this. There we go. And there we go. So again, a schemaless model that's defined, and you define its model properties on the Angular client. So that's lesson 1. Lesson 2, real quick now, illustrates existing data. So we've acknowledged at Loopback that enterprises have existing data, and that although it's nice to define new data for your mobile apps, you want to leverage your existing data. So I'm going to go ahead and rerun the application now. And instead of connecting to our memory adapter, we're going to go ahead and connect to a running live instance of Oracle. And just to give you a flavor of what's going on here, loop. All right. Table name. User tables. And go ahead and describe inventory, actually product. That's what we're going to be showcasing here. And I'm going to get back basically the records that are going against this Oracle database. So what's going on with this is we're calling controller that's basically sending requests. And what's nice about Angular is that it's very easy to figure out what's going on with these controllers and what they're doing. So in this case, I'm simply hitting up weapons, which was linked through loopback to the products table, querying it, and getting back and binding that to this view. And again, through the power of, as Val put it, data binding being bidirectional, there's a whole slew of things you can do here. From a mobile applications perspective, you will have issues like data sync, like save eventually, save and forget, but this gives us a rich interface to be able to meet the demands of what you would normally build within the native platform. In the interest of time, I'm going to stop there and continue on with concluding out Loopback. So that's the demo. If you'd like to go ahead and follow along or follow up, go ahead and go to the quick starts. We have quick starts again for all 3 components. A quick look at the roadmap. So we just released this literally 2 weeks ago, and we're solidifying our JavaScript SDK. We just finished Android. That's in testing right now. As an MBAS, part of the reason why you would want to adopt an MBAS is because we want to actually pre-build mobile models for the most common use cases. So like user for user registration, file for storing files and other clubs. LB GeoPoint is our GeoPoint for geonavigation and other calculations on the mobile device. And of course, push notification. We're also working on an editor, again, all in Angular, that makes it even easier so you don't have to navigate through code if you don't want to or use the CLI. And mobile app management, so how to actually develop your apps that actually tie in backends with your APIs. And of course, more connectors. We have MySQL that's already done, and we're looking to evaluate enterprise systems. So what's next? Go ahead and please try Loopback and register on our site. We have their docs page, as I mentioned before. We also have a community that we've established called Node Republic that we sponsor. And if you have any questions, please feel free to contact me. Here's my contact information at the end here. And that's pretty much it. Back to you, Brad.
Wonderful, Al. Thanks so much. I know I've already had breakfast, but for some reason I'm hungry for bacon here at the end. I want to thank all of our speakers, Val, Ward, and Al, for joining us this morning. And for everyone watching, thanks for joining. We will see you on the web. Please ask us questions. Please try out these technologies. We're excited to see what you guys build. We'll see you later. Bye-bye.